So in example 2, the rational function is the quantity 3x minus 6 over the quantity x squared minus 2x minus 8. In general, the very first thing I do is factor everything so I can pull information off without having to do a lot of writing. So in the numerator, we can go ahead and factor out a 3. That'll leave me with x minus 2. The denominator, that factors into x minus 4 and x plus 2. Notice there's nothing in common we can cancel. We'll do an example of where we do have something in common. You always want to make sure it's in simplest form before you go to graph it, but there's nothing to cancel. So we can go through our steps. So again, the first step is that x-intercept. That comes from the numerator. When you set the numerator equal to 0, right? You divide the 3 out of there and get x minus 2 equals 0. So x is equal to 2. So that's our x-intercept. And again, you may not have needed to do any writing whatsoever. You may be able to just look at it and identify it. The next step is that y-intercept. Here we're going to go back to the original form. It's harder to pull it off the factored form, so I'll go back to the original form. And in the original form, anything that has an x is gone. So we're going to end up with a -6 over a -8. Well, that reduces to a +3/4. So our y-intercept is over there at 0,3/4. Next is the vertical asymptote. The vertical asymptote comes from the denominator. We can see that we have a problem at 4 and -2. So our vertical asymptotes are going to be x equal to -2 and a +4. And you can write them as 2 separate lines, or you can write it that way, it's your call. Next is the horizontal asymptote. This comes back and looks at the degrees. So the degree of the numerator, num, the degree of the numerator is 1. The degree of the denominator, well, it's got an x squared. So that's a 2. So it's bottom heavy, is what I like to call it. And anytime it's bottom heavy, I know that the horizontal asymptote is that x-axis. That's the line y equal to 0. Again, because it has a horizontal, I don't go look for an oblique because I already know I've satisfied that question. So again, there's our information. It didn't take a lot of writing. It didn't take a lot of doing. It isn't a lot of analysis, though. You do have to think about what it's telling you and where each piece of information is coming from. So then we can come in and bracket. So an x-intercept at +2, a y-intercept at 3/4, so not quite 1. We have a vertical dotted line over here at -2, and another one over here. X equals 4, and x equals a -2. We also have a horizontal line. It's sitting right on top of this axis. I can use a colored marker to show it. A highlighter works really good if you're working on paper to show it. There it is. And there's our horizontal asymptote. Okay. So this time we have 3 regions. So we have region 1 on the left side. We have region 2 that's between the two, the goalpost kind of thing. And then we have region 3 over here. We need a piece of a function in each one of those, and they're all functions, so it has to pass the vertical line test. So doubling back on itself, basically. Okay, well, I'm going to go for the middle just because it's the easiest place to go for, because I have 2 points. I have this point and this point. So it's got to start by this vertical asymptote in that middle region. So to start by the vertical asymptote, if it were going to come up from the bottom, like this, it would have to cross the x-axis to get to that y-intercept. We don't have a point over here. So I know it's not starting from the bottom. It has to come down from the top. So we're going to come in next to that vertical asymptote up to positive infinity in terms of y. We're going to hit our y-intercept. We're going to go to the x-intercept. Now, what's it going to do there? Well, it's either going to pass on through or it's going to bounce. That depends on the multiplicity. Good thing we know about multiplicity. So the multiplicity of that x-intercept is coming from the numerator, and its multiplicity was a 1, which the graph tells me is going to cross. So it's going to head towards that vertical asymptote and head down. If this had been an x minus 2 quantity squared, it would have bounced at that, but it doesn't. So, yay! Okay, now what? Well, you can test the regions, or you can rely on the fact that if this is headed up towards positive infinity, then this would be headed down towards negative infinity. And again, you can test something like x equal what? -4, which is in this region. If I plug in a -4, I have 3 times -4 minus 2 all over -4 minus 4 over -4 plus 2. And I really don't care about the number itself. I'm really after the sign. So we're trying -4 over here. So 3 times a negative is a negative. So the numerator is going to be a negative. -4 minus 4 is a negative. And -4 plus 2 is a negative. And 3 negatives make it negative. So sure enough, it falls below. So I didn't need to do that, but if you didn't trust the fact that it's above over here, so it's got to be down over here. Using that same kind of logic, because it's below on this side, it's going to end up being above on this side. Again, you can test, use something like x equals 5. This is a 4, plug in a 5. 3 times 5 minus 2, all over 5 minus 4 times 5 plus 2. 5 minus 2 is 3, times 3 is a positive. 5 minus 4 is a positive. 5 plus 2 is a positive. And 3 positives make it a positive. So sure enough, it's above. What I'm mimicking is that 1 over x graph. It's not a 1 over x squared. If it were 1 over x squared, then I'd see that kind of volcano approach. But I don't have any multiplicities that are double, so I know pretty much it's going to alternate regions. So if it's below here, it's above here. If it's below here, it's above here. So I tend to use that to help me graph. Fantastic. Comments or questions about that one? Next one we're going to do, example 3. Example 3 says f of x is equal to x squared plus x minus 6, and that's going to be all over x minus 1. So again, the first thing I'll do is factor it. That's x plus 3, x minus 2, all over x minus 1. Okay, we'll walk through our steps. So our x-intercept, that comes from the numerator. If you set the numerator equal to 0, we're going to get 2 of them. One's at -3, 0. The other one's at 2, 0. -3 coming from the first factor, positive 2 coming from the second factor. The y-intercept, again, go back to the non-factored form. If all the x's are 0, you're going to have a -6 over a -1. Well, that's a +6. So the y-intercept is at 0, 6. Vertical asymptote comes from the denominator. The denominator of the function blows up when x is equal to 1. So that's our dotted line in the vertical direction. Okay, what about the horizontal asymptote? So now we're going to come back and look at the degrees. The degree of the numerator is 2. The degree of the denominator is 1. So this one is top heavy. That tells me that instead of having a horizontal, it is oblique. So we're going to take what would have been a nice horizontal dotted line and we're going to tip it one way or the other. So how do we find that? Well, we're going to do division of the polynomial. So we're literally going to come in and take the top polynomial and divide it by the bottom polynomial. Now, in our textbook, the problems are pretty much what we call canned problems. They're designed to work, and case, they're actually designed to work using synthetic division. So I'm going to divide these out using synthetic division. So I'm going to put the 1, and then we'll have a 1, and a -6. So the 1's coming from the denominator. Here's the coefficients in the numerator. So pulling down the 1, multiplying, adding gives me 2, multiplying, adding gives me -4. Yeah. We didn't get a 0. I don't expect to get a 0. If I got a 0, that tells me that something could have canceled top to bottom, and I don't want that. So instead, we're just going to ignore the -4. Why can I do the -4? Okay, let's backtrack. What we're looking for is the behavior of this graph out there at infinity, positive infinity and negative infinity. So if I'm out there at positive infinity, do I really care whether I'm adding or subtracting a -4? No, same thing. Negative infinity. That -4 is meaningless when you're dealing with huge, really big numbers or really tiny numbers. So that's why we can ignore it. What about this though? This is the important part. So if we put our x's back on it, this is x plus 2. I'm going to put a y in front of it, and sure enough, there's our oblique asymptote. There's the equation of the line for the oblique asymptote. So synthetic division works really good. That's why we did all that first. So back over here, just to keep track of my information. My oblique asymptote is the line y equal x plus 2. Okay, now we can graph it. We have all the information. And again, it has an oblique. It does not have a horizontal. So we have a -3 and a +2. We have a +6. 6. Okay, so there's all the points. We know we have a dotted line over here at +1. I hope yours went through it. Okay, now we're also going to have another dotted line. So what was horizontal is going to get tipped. So we know to graph this line that has a y-intercept of 2. I'm going to use an open circle because I don't want to confuse that as a point on my graph. So it's an open circle for me. We know the slope says to go up 1 over 1, up 1 over 1. So from here, I'll go up 1 over 1, up 1 over 1 until I feel comfortable enough to make my dotted line. So be there. So it's going to come in and do something like this. And that's the line y equal x plus 2. And it's our oblique as we only have two regions, to the left of the vertical and to the right of the vertical. So I have this side and I have this side. Well, on the left side, I have 2 points. It's got to go through here. It's got to go through here. This x-intercept, this y-intercept. It's got to start by that horizontal asymptote because that's the only thing that's out there in infinity. We're going to start right above it. We're going to smoothly cross those 2 intercepts and head on up. As soon as it hits that vertical asymptote, it's going to be pushed up. So it's this nice, smooth, gentle curve sitting in there. On the right side, it's either going to be above it or below the horizontal. Well, if it were above it, I'm sorry, let me rephrase it. I know it's below it for 2 reasons. I've got this alternating pattern kind of thing, and I've got an x-intercept sitting down here, so it's got to cross that x-intercept. So we're going to start below the vertical asymptote, or right next to the vertical asymptote on the bottom, and head to that x-intercept and then off towards the horizontal asymptote. And there it is. There's your graph of this rational function that was top-heavy with an